Picture this. It's the near future. The whole world is watching as the Artemis 2 mission just streaks across the blackness of space. It's this incredible testament to human ingenuity. But this is way more than just another flight. It's a true giant leap, pushing us further than we've ever been before. And we're about to dive into the incredible, kind of hidden story behind what made it all possible.
Pushing beyond that frontier. Can you imagine hearing those words from Mission Control? It perfectly captures that spirit of exploration that's been driving us for, forever. The Artemis 2 crew, they weren't just walking in the footsteps of giants. They were blazing a whole new trail, kicking off a brand new era of space exploration.
And this is the headline. 248,655 miles. That is the exact moment the Artemis 2 crew smashed a record that had been standing since the Apollo 13 mission in 1970. Think about that for a second. They officially became the humans who have traveled the farthest from home. Just a staggering, unbelievable achievement.
Okay, but here's where the story takes a fascinating twist. How on earth is this modern-day, high-tech spectacle connected to the work of a brilliant physicist from Ghana all the way back in the 1960s? We're talking about Professor Francis Allotey. And it turns out his theoretical work wasn't just interesting, it became absolutely essential for missions like Artemis. So let's connect the dots.
To really get this, we've got to jump in our own time machine. We're going back to the mid-20th century to a really specific problem. A puzzle that had some of the world's best physicists totally and completely stumped.
So the problem was basically a massive gap between theory and reality. Scientists had all these super complex mathematical models that were supposed to predict how matter behaves on the tiniest scales. The only problem was, when they actually ran the experiments with something called soft X-rays, the numbers just didn't add up. The theory said one thing should happen, and reality showed something completely different.
And this right here perfectly shows that gap. Their models were broken, and it was because they were missing a key piece of the puzzle. They were running all their calculations without thinking about the effect of this tiny hole that gets left behind when an electron gets knocked out of its spot. Now, that might sound like a super small detail, but believe me, in the quantum world, a detail like that changes everything.
And this is where the hero of our story steps in. Professor Francis Allotey, a brilliant mathematical physicist from Ghana, looked at this same puzzle. But where others saw a dead end, he saw a chance for a massive breakthrough.
He went on to develop what we now call the Allotey Formalism. And you can think of it like this. Physics needed a new rulebook, a new instruction manual for this one weird phenomenon. And he was the one who wrote it. He was the very first person to create a mathematical model that actually included that electron hole. And poof, the theory finally lined up with reality.
And you don't have to take my word for it. In his own words, Professor Allotey just lays it out so simply. He's basically saying, look, all the old theories just didn't match what we were seeing in the labs. My math does. His work, his calculations, were the first to get it right, solving a puzzle that had honestly baffled the physics world.
Okay, so a super complex physics problem from the 1960s gets solved. That's really cool for physicists, right? But what in the world does that have to do with astronauts flying around the moon? Well, let's see how this piece of pure theory turned into a tool that is indispensable for space exploration.
And here it is. This is the aha moment. Professor Allotey's breakthrough math wasn't just some abstract idea meant to live on a chalkboard. It became an incredibly useful tool for a really important job: figuring out what stuff in outer space is actually made of. His theory gave scientists a brand new way to analyze materials from millions of miles away.
And that is precisely what happened. Of course, NASA recognized just how powerful this technique was. The Allotey Formalism was adopted and applied by the space agency, and it's become a fundamental tool that helps scientists understand not just what things are made of out there, but also the chemical reactions happening across the cosmos. It's this unseen but absolutely vital part of exploring space.
Professor Allotey's story is such a powerful reminder. The giant leaps we get to see today are so often built on the quiet, foundational work of these brilliant minds who came before us. And his legacy? Well, it's truly a story of firsts.
Just look at this timeline. It really puts his incredible journey into perspective. From being born in Salt Pond, Ghana, to earning a doctorate from Princeton, to becoming the first Ghanaian full professor of mathematics at his university. His entire life was a testament to breaking down barriers and just relentlessly pursuing knowledge.
And then, in 1973, his world-changing work gets this massive recognition. He was awarded the prestigious UK Prince Philip Golden Award for his breakthrough.
This wasn't just some small prize. This was a major international acknowledgement of just how important his work was.
And let this one sink in for a minute. In 2004, a book comes out listing the 100 most eminent physicists and mathematicians in the entire world. Professor Allotey was the only one from the whole continent of Africa. I mean, that just highlights the sheer global significance of what he accomplished and his unique place in the history of science. Which brings us right back to where we started. When we hear those Artemis II astronauts talk about honoring their predecessors, they're probably thinking about the Apollo crews, right? But now we know better. We know that honor extends so much further, to unseen giants like Professor Francis Allotey, whose foundational work literally made their journey possible.
So, as we look ahead to the future of exploring space, to Mars and who knows, maybe even beyond, it really leaves you with a question, doesn't it? Right now, somewhere in a lab or in front of a computer, someone is solving a puzzle that seems totally abstract. But their work, their unseen work, just might be the force that powers humanity's next giant leap.